Again, welcome to CS 435 class. That's data structure and algorithm using Java. In these lectures, we're going to study about linked lists. So our main objective is to learn about linked lists, also to study the basic properties of linked lists. We're also going to explore the insertion and deletion operations on linked lists, and also how to build and manipulate a linked list, and how to construct both double and circular linked lists. Again, double and circular linked lists, we will not go more detail on it. We are going to cover that in a different lectures. And these lectures will focus on a simple linked list. So what is a linked list? Here we say a linked list normally consists of lists of items, which we call the nodes. And the order of the nodes is determined by the address called the link stored in each node. So in a simple linked list, the node will consist of only two parts. One part is for the information, the data that we are storing, and the other part will be the address of the next node that is point to. So the address of the node will determine the order of the linked list. So here we say every node except the last node contains the address of the next node. The last node normally will point to null. So if we want to check if a linked list is empty, we can just check if the first node is point to null. The first node is the special node that normally points to actual first node in the linked list. They use the term first or special node. So again, the component of a node, as we said, is two parts. The data will store the relevant information, and the link normally stores the address of the next node. So this is a diagram for a linked list. So the structure of a node, this is again a simple linked list. So you have the information part and it has the address part. The link will be the address of the next node that is pointed to. So example here, we have a linked list. The special node, which sometimes called the first node or the head, is the node that points to the first, again, node in the linked list. So this means our linked list, the first item will be 45. And we can see the link again is point to the next node. So our next node, the item is 65, and the address session is the address of the next node. So in this case, we have a linked list with 4 items or 4 nodes. You can see the last node point to null. So what is the head? Or sometimes we call the first. So the head or the first is the node that holds the address of the first node in the list, the actual first node in the list. So the info part on the node can be either a value of a primitive type or a reference to an object. So it can be a value of any type of data, whether character, integer, whole number, decimal, etc., or strings also as objects. So here, in order to implement a linked list, first we must have a class node. Since again, a linked list consists of, again, nodes, we may have the class node, and the class node will be used by the linked list class. So here, normally the class node will represent the nodes on the list. As we said, a node have 2 parts. So a class node will have 2 instant variables, the info part and the link part. The link part, the type will be the node, since it's the address of the next node. It's pointed to address, so the type is node. The info can be any data type. Here we use the int, or it can be any data type. So this is an example of a class node. Again, the name is node. That's the class name. We have the keyword public and class. And as we said, again, it has only 2 parts. So we have the info and also we have the link. The link will be the address of the next node. The info is the data that the node contains. So here they say we should notice that the instant variables are public, very important, because we know by tradition in object-oriented programming in Java, our instant variables are always private for security reasons. When an instant variable is private, basically it means other classes in the program cannot directly access it. But here, we want linked list class to access the node. So that's why we make the instant variable public. So here we say, notice the instant variable of the class node are the class public. The reason why, so that the linked list class can directly access the instant variable of the class node, since it's going to use it. If we make it private, then the linked list class cannot access it directly. So again, this is an example. We have a linked list with 4 items. And as we said, each node have 2 parts. We have the information part. So here the data type here are int. That's a whole number. So here, just for simplicity, we say the address also will be in int data, integer data type. So the head is 2000, that's the address, and which means the address of the first node is 2000. So here we can see the first node address is 2800. That address is for the second node, and the list keep going. So each node have 2 parts, the info, the information, and the top 2000 here represent the address of the node, which is carried by the previous node, which is the head. So this is a linked list with 4 nodes. The last node point to node, so the address is node. So let's see some few linked list properties here and also the operation. So for example, we are going to refer to our previous diagram. When we find the head will have only the address of the next node, which is 2000 from the diagram. Head value is 2000. Same thing, I can say the head.info will be 17. Head.info or head.link will be 2800. Head.link.info will be 92. So that's the concept. So here we start with the head. Head is 2000. So head.info, as we saw in the previous, again, it will be 17 because head.info. Now head.link again, and .link and info will be the last value 45. So that's the example here. For example, head.link is 2800. Head.link.info, that will be the second, because the head link means we are in the first node, and the first node carry the address of the second node. So the second node info is 92. So this is also, we should consider. Now, the one issue here is that if we have a linked list with only the head pointer, if we want to transverse or move through the linked list, if we use the head pointer, what will happen is that when we move from one node to the next, that node will be out of the linked list. So for example, if I move the head pointing the first node to go and point the second node because I'm moving through it, what will happen is that the first node will not point to anything. So this means the garbage, Java garbage collector can again remove it. Simply we are deleting it. So if we transverse through the linked list with the head pointer, we are going to delete everything. So that's the idea here. In order to transverse, what we do, we create a second pointer, which we call it current. To create a second pointer, we assign the head to the current. Now, I can use the current to move through the linked list, and we still have our linked list intact and not deleted. So for example, if I want to move to second node, I can use current dot link. So which means instead of the current to point to the first node, it's going to point to the second node. And if I say current dot link and link again, it will point to the third node. So the first execution we have here again is to create our first, the second pointer called the current. So we assign the head to current. So which means if I say head assigned to current, it means where the head is pointing to, the current also is pointing there. So that's why now we can see the head and current both is 2000 and they are pointing to the first node. Again, the current is the address of the next node. Here again, for simplicity, we use the address as 2000, but normally, again, this address will be in a hexadecimal numbering system. So that's the idea here again. Now the values of current and some of the nodes of the linked list, we can see this is almost the same as head. Since we assign the head to current. That means it's to start from that position. So current value will be 2000, current.info will be 17, current.link will be the address of the next node, that will be 2800. 2000 is the first node address, the second node address 2800. Then current.link, we are in the second node, and we need the info of the second node, which is 92. So you can see here, the second node info is 92. So this idea is very important. It will make us to understand the code when we start to implement the linked list. Now we should understand how the whole structure works and how the operations that we can perform on them, etc. So now we assign current.link to current, which means what? We are moving one step, because anytime we say .link, it means the address of the next node. So we can see the diagram now. Now current become 2800 is pointing to the second node. So this means if I want to transverse through the linked list, all I need is the current.link assigned to current, or current.link.link assigned to current, which means it moves 2 steps to 2 nodes ahead. Now we are in a different position, and we are in the second. Now current is pointing to the second node instead of first. So which means now our current address will be 2800 because the second node is 2800. Then current.info, we are going to stand at the second node and see the information for that. So that's why it's 92, not the first node no more, second node, because it's pointing. Now I'm already in current to the second node. Now if I execute another current.link, I'm going to move to the third node. So I'm going to point to the third node. The address there is 1500. You can see the diagram. So 1500 is the third node. Then we need the current.link.info, that is the third node information. So it should be 63. 63. So these are some of the operations, again, examples here. For example, we have head.link.link. Again, it will move twice. So it's 1500. We assuming we are in the beginning, head.link.link, 1500. We have again head.link.link.info. So the information on the third node. You can see it should be 63. 1, 2, 3, the third node 63. Because the address there is 1500. Then we keep going to the end. Now we have current.link.link.link. So 3 times. So let's see how that works. So we are here beginning current.link.link.link. So the address of the last node is null. So that's why we say the value is null. Now if I say current.link.link.link.info, we don't, in the link address, we don't have next node that is pointed to, that's the end. So does not exist. So now let's see some operations. First here we see the transversing a linked list. That's going through the linked list, visiting each node in the linked list. So here we say, what are the basic operations that will make us to visit the nodes in the linked list? One of such operation can be search. If I want to search an item in a list, I have to go through each one. In general, we have two types of searching, which we call the linear search and also the binary search. So the linear search, we start from beginning to the end. Binary search, we have to make sure that the list of the item are sorted. So we start from the middle. That's why it's called binary. We divide the list into two, take the middle value, compare the middle value with the search key. If the middle value is greater than the search key, then we are going to search the lower part, half of the lower part that is left. This means we are going to eliminate half of the higher part. Then we'll repeat the same process. We look for the middle value and compare to the search key again. If it's the same, we'll return it. If it's higher, then we go to the higher part of the. So in this case, we are going to ignore the lower part. So every run, we are going to eliminate half of the list. And this makes binary search far better for large values comparing to, again, linear search. Linear search, very straightforward. We start from the beginning, we search the items until we find it. If we don't find it, then let's say we return -1 or something. The item doesn't exist in the linked list. So that's the whole concept. The second one to set. Now, why do we insert an item in a list? We have to do transversing because linked list is not like array. Array means that we cannot insert item between the indices. But with linked list, we can insert an item anywhere. So I can shift, let's go back to the diagram. I can insert an item between, let's say a node between the second and third node or between the third and fourth node. So this means I have to do some transversing. I have to move the pointer to the right location and then assign. So inserting an item, we have to go through and also delete. I can delete any node. So still I can transverse through it. Now here say we cannot use the head, as we said earlier, to transverse the list, because if we use the head and that's the only pointer, anytime we move to the next node, the previous node will be removed from the linked list. So that's what we said here. You will lose the nodes of the list. We should use another reference variable of the same type as head. Example here, we say current. It can be any name, you name it. But the first thing is that we are going to assign the head to the current. Then we use it from there. So the head will stay so that we maintain the linked list. So now let's see a few code. Again, in our next lectures, we will do the implementation of the linked list. Right now, we just want to understand the theory behind why do we need a linked list and how linked list works. So the foreign code will transverse the list. So as we said earlier, we create a new pointer. So we assign head to current. So now current is what we are going to use to move through the linked list. So here, since we are going through and visiting each linked list, we are going to use the while loop, repeating the concept. So here we say why the current not equal to null, which means we haven't reached the end of the linked list. Then what we do? We move one step at a time, one node at a time. So we assign the current.link to current. So this will process the current to move from one node to end until the condition here is true, which means until we reach the end of the node. We know the last node point to null. So if the last node point to null, when the current become null, then we can't go no more. So that's where we terminate the while loop. So again, this is a very short code to transverse through the list. Create a new pointer here. We call it current. Our original pointer is called head, so we assign head to current. Then we say why current not equal to null. We haven't reached the end of the linked list. Then let's visit one node at a time. So we say current.link assigned to current. Now the next is the following code, output the data store in each node. Since we're going to output the data, the same thing, we have to transverse or go through the linked list. So while we haven't reached the end yet, the current not equal to null, we just print the info part. Remember, the variable name is, the variable names are very important. So he has a system.out.println, which is the Java language to print an item. But here we say current.info, which means the pointer where it reached, the node that it reached, the info there, we want to print it. Then we increment the pointer to move to the next node. So we say current.link assigned to current. So this statement will print all the informations or the data in the linked list. The condition say until our current reach what? Null. If it's not null, then we should keep printing and visiting. Current.link assigned to current will make us visit each node once at a time. Okay, let's see the next one, item, inserting and deleting. So to delete an item from a linked list, we need to perform some few operations. Actually, both insertion and deletion, we need to control the pointers. So if I want to set a new node in a linked list, first we need to create the node first. We need a node. So when we create a node, we assign the information to it before the pointer to join the linked list. So here, first of all, we create our class name node. So we are using a variable info to put our data in the node. The variable link will carry the address of the next node. So if we have our node now, the next thing we need is our pointer. So here we are using P and Q. Remember we said we also have the head. The reason why we are using P, we can use only P, but when you are inserting, we have to be careful not to reference the pointer back to the beginning of the node. So if we have two pointers, it's better. One will point to the previous node and one will point to the next node if we are inserting between two nodes. So that's the whole concept. So the new node here is just the variable for our new node name. And then the node here, the class name, which will be the data type also. So these are the variables we need. Now, why we assign head, remember head carries the address of the first node. So the type will be node. P and Q will be our pointers. And also, this also the data type will be node, new node. That will be the variable when we create the new node. So this is consider the following linked list. We have original linked list with 4 items. Now, what we want to do now is to insert an item. As we said earlier, with the linked list, we can insert the item anywhere we want to. At the end, the beginning, between two nodes, that's fine. The only thing we have to manipulate our P pointer. And inserting between two nodes is good to have two pointers like P and Q, so that if I'm setting between 65 and 35, I will assign Q to 34 section. I'll assign P to 65 between the two nodes. So as we said earlier, the algorithm of inserting a new node in a linked list is to create your node first. So you want to create a new node. When we create a new node, we have the information part. We said, for example, here we insert 50 into it. And here we're going to insert it after P. So this is the code now. The following statement create and store 50 in the info field of the new node. So new node equal to new node. This is the, we know the new keyword dynamically allocated memory space for either an object, variable, etc. But here we are creating a new node object. So this will create a new node for us. Then next, we assign, since we know this is a class, and the class node have info part. So we say new node.info. The node here is the constructor. So normally in one sentences, we can write the name of the class, which is the data type. So node, new node equal to new node. Then since the class, again, node have info, instant variable, it has also the link instant variable. So we can, since those two variables are public, we can directly access it. But here again, we are using just the node class to create our new node. We assign 50. So it will look something like this. So far we haven't set the new node yet in the linked list, just creating it. Now, next step, we are going to do the insertion. So what we did, we assigned the p.link to new node.link. So this will take us back here. Let's go back to the diagram. If we say if we are here p.link means we are going to the next node. So here we want to insert it. We assign p.link to the new node.link, which means what we are doing now is that we are saying that the p.link, we are going to give it to a new node. So we assign the new node. We are assigning the p.link to the new node link. So it's going to point it. Then after that, we also assign the new node to p.link. So the sequence of the statement to insert the node is very important. Here, first of all, we have to assign the p.link side to the new node.link. Then we assign the new node itself to the pin link. If we do it the opposite way, what will happen is that the new node, the pin will be referencing to itself the new node. And so the sequence, that's why here they say the sequence of statement to insert the node is very important. Now, if you reverse the sequence of statement, you will not get a desired result. What will happen is that instead of the pointer to point to the next node, it will point to itself again. Because first you say new node assigned to p-link. You assign the new node to p-link. Then you say the p-link should be assigned to new node.link. So it's like the same. And I think we have the diagram somewhere. And no. So this is the idea first. List after, normally the previous one, like the diagram will be, instead of the P pointing, as we can see here, we assign the P to the new node. So it will be the opposite way. So it will reference to itself, which means here we have the new node link pointing to the, which means the address of the next node. But if we assign the P back to its link, it is saying that we are going back again to the previous node where the link, because the P is point to 65. So we don't want to assign it to back to 65. Now, this is the best way. The first, we have p.link assigned to new node.link. So this is what we get. P.link is point to 34. So if we assign p.link to new node.link, we are saying that now new node will point to 34. But if we say new node.link first, the new node.link will point to p-link. It means instead of 50, the new node to point to 34 is going to point back to 65. Then when you point back to 65, and then you go the opposite way, for example, you say new node to p-link. So the new node will go to 65 because that's where p-link is. Then since 65, the link here is already in 65. And now the next step, we say the p-link to the new node link. It will code this, so it's like looping. So there's nothing to point to 34. That's why the order is very important. First of all, you assign the p-link to the new node, which means P-link is point to 34. Now we want new node also to point to 34. Then next we say the new node should assign to P-link. Okay, now the new node should go to P-link where P-link was before. So this section will be point to 65 as we can see P-link. So in this case, we are inserting the new node between 65 and 34. Perfect. But this is the problem. If we do the new node, as we said, new node point to P-link first, it means the new node will go to P-link 65 first. Then when you say P-link back to new node link, then P-link will go to new node link. It won't go to 34. So the best way to avoid this is to do the double pointers. So for example, now we have P and Q. We make sure Q is ahead of S once. So we may say we assign P.link to Q. Now, if you have two pointers like this, it doesn't matter no more. So this insertion worked perfect. I will assign Q to new node.link because Q is ahead of P. Then I'll assign new node to P.link. Or I can assign new node to P.link and I can assign Q to which it doesn't matter the order. The order in which this statement execute does not matter no more. I'm using two pointers, one in the front, one in the back between. So that's the insertion. When we do new node to P.link, you can see 65 come to 50. Then we do Q new node.link. So new node.link is here, Q, we get it here. Now deletion. Here, for example, we want to delete node with the info 34, which is this. As we said earlier, deletion is about just moving the pointer away. So here you can see we say P.link.link assigned to P-link. So what we are doing, P.link will give me 34. P.link.link will move from 34 to 76. So P.link.link assigned to P-link, we get this. Then now we need to the P and the 34 node previously is point to the last node. So we want the second node to point to last node. So that's why we move the P twice. Now we have to deallocate the 34, remove the pointer from there. So the previous statement remove the node. However, the memory still be occupied by this node. So we don't need to worry. The GC, the garbage collector system.gc, we can run it, automatically will be removed. So here we can see that 34 is not point to previous. So this is will be removed. We have to remove it, either calling the system.gc or the automatically remove. So this is how we should conduct using two references variables. We can also simplify the codes for deletion. So we assign same thing as we use the two variables for insertion. We mean to say this P and Q, Q is ahead of P, and we do the, so the same concept here also. We assign P.link to Q, which means we let the Q move one step, as we said earlier. Then we say Q.link assigned to P.link, which means we are moving away. P will move to Q. And so what will happen is the diagram here. If I assign P.link Q to Q, so Q will move one step ahead. Now, after Q move one step ahead, we say, okay, now we want to assign Q.link to P. So this means again, P also will move one step. Then we make sure assign node to Q. Then we call the system.gc to again remove the node that is dereference. So again, first P.link execute. So we can see Q is in front of, so we say P.link assigned to Q. So Q is in front of P. The next step, we say Q.link should be assigned to P.link. That means they all go in the same P and Q are going to point the same node. So now instead of P to point to 34, it's pointing to 76, the same node as Q. So now we need to, 34 is the reference, so we need to remove it. Now the next is building a linked list. We can build a list in two ways, either forward or backward. So with the forward, a new node is always inserted at the end of the linked list with forward, and the end of the linked list is where the pointer points to node. Now with the backward manner, the new node always points at the beginning of the linked list. So this is the algorithm or the step building a linked list forward, which means we have to set the new node at the end of the linked list. So what we need three reference variables. One will point to the front of the list. We cannot move that one. The one will point to the last node of the list, and one to create the new node. We are building a linked list, so we need to create a new node. So the next two slides will show how the code is written, or how we create the code forward. So again, building linked list forward. First, we need a variable name first, and also variable name last, and then the new node. This will tell us the first and last in the linked list. Then we have the norm, variable int norm to get the value. So now we say system data, enter integer ending with 999. And now and negative 999, so this will be a sentinel value, sorry, negative 999, not. So now we ask the user to enter the number. We assign null to the first, which is, we are building a new linked list. There's nothing inside, so the first item is assigned to null. And again, user enter negative 99. That anytime the user enter negative 99, then we stop building the linked list, adding node to it. So we are using while loop. While num not equal to negative 999, what we do? Create a new node. After you create a new node, add the value to it, the num. And the value is what we enter first. So that's why I say int num here, we take the value that we are going to enter into the node. So when we enter the value into the num, as far as we didn't enter negative 999, we can add a new node, create new node, add a value, then assign null. So it will be one at a time. So we assign null to the link of the new node. Now, when we assign link to the new node, we check if the first equal to null, that means the linked list doesn't have any value. And remember this, we are building forward, so we have to insert at the end. So here we say, okay, if first equal to null, our new node will be the first. And of course, our new node also will be the last, because it's only one item, so it will be the first and last. Else, that means first is not equal to null. There's already some nodes in the linked list. If there's a node in the linked list, remember building forward means we are assigning the new node to the last address, the last node. So we say new node assigned to last.link. Then that new node will be last, because building forward, we assign the end. Then we ask the user to enter a new number. If the condition, if it didn't enter negative 999, we follow the same process until you enter negative 999, then we stop the while loop and we end the build list forward. So the condition of stopping the while loop or stop building, adding item to the linked list, is the user must enter negative 999 to stop it. Now, building a linked list backward is opposite now. But this time we need only two reference variables, since we don't care about the last. Because we building backward means we insert from the front. So we don't need the last. So one point in front of the list, and one is to create the new node. We don't need last no more. So the next slide will show it. We have our first new node. That's it. We don't need last pointer. This is the value we are going to enter into the node anytime we create it. So we ask the user to enter the value. Again, we are using -999 again as a sentinel value. When the user enters the value, we assign the value to first. And we assign no to first. Then we say why the norm not equal to -999. We build our new node. We store the value there. And then we also store the first to the address. Because when we are inserting backward, that node becomes first node now. So we assign the special node called first, or the address of the first node in the linked list. So that's why we assign first new node.link. Then we say new node assigned to first. We ask the user to enter a number again, the number for the next linked list. So this is our while loop. We keep going until -999 is entered, then we stop building the linked list. And we return first. And that will be the end. So that will be the conclusion of our linked list. The main goal of these lectures again is to understand the theory concept and there's a few basic operations, example how to build the linked list either forward or backward, how to insert an item in a linked list, how to delete an item in a linked list, and the linked list consists of what? The nodes, and also what is a node. So again, wish everybody the best and see you in the next class, which will be the ADT of linked lists. That's abstract data type of linked lists. Thank you.